Hi, this is Ms. Park, and in this video we're going to have a quick introduction to Desmos graphing calculator, and we're going to learn how to draw graphs from an equation and also from a table of values. So Desmos is a website, www.desmos.com. When you get in there, you'll click on graphing calculator, and it'll open for you a grid. And in this space here at the top left, there's just an empty space. This is where we're going to put what we want to graph. So let's say I start with something simple, like I want a straight line, y equals mx plus b. So let's say I want to graph y equals 3x plus 1. So I'm just going to type my, my formula into here, y equals 3x plus 1. And Desmos will graph for me this line. So if you recall that the plus 1 means that there's a y-intercept of 1. We can see that here on the graph. And the 3 means that there is a slope of 3. So if I pick any 2 points, so let's say I take my y-intercept and this other one over here, 0.5, 2.5, I can see that the rise is 3 boxes. Now watch the scale. Each box is a half. So the rise is 3 boxes, 1.5, and the run is 1 box, which is 0.5. 1.5 divided by 0.5 is 3. Rise over run is 1.5 over 0.5, which is 3. So we can see that it has graphed the line y equals 3x plus 1. Okay, so that's how you graph. Now there is a keyboard. Down at the bottom, there is a keyboard where you can type in lots of things. You can put exponents, you can put square roots, you can type numbers, so you can play with that. You can put x's and y's. And actually, it doesn't even need the y equals. It knows that things to graph begin with y equals. So even if you just put the 3x plus 1, it'll still graph the same line. Okay, but I'll put the y equals 3x plus 1 just so that we don't get confused. Okay, so now what I'm going to show you is how to draw the graph from a table of values. So to create a table of values, you simply type the word table, T-A-B-L-E, and it'll draw for you a table. So you have your X and your Y, and you can just type in values. So I'm just going to take a textbook question, and I'm going to take a moment and type in my table of values. So this is just from the textbook. I will see what this looks like. So give me a moment to put them in. You can look at the screen in the meantime and see what's there. And 4 is 18.0, and 5 is 21.0, and finally 6 is 24.6. Okay, and so I have this table, and we don't see anything on the grid. Well, that's because my y's only begin at 12 and then they go higher. So I can scroll, I can zoom in and out. I can also hold down the right mouse button and scroll. I see I made a mistake with one of them, so let me just check all my numbers. No, no mistake. Yeah, there's the mistake. Okay, the last one is 24.6. Okay. All right, so now when I look at it, I can see that the dots follow a curve, okay? But suppose I don't know an equation for this curve. Let me try and put a straight line to it. So what you could do to Desmos is you could say to Desmos, okay, I have these points. Can you find an equation that fits these points? Okay, and that's called coming up with a model for the equation. So a model for the equation, a model for the data is some equation that fits these points. Okay, so let's say I want to fit a line to these points. So I want Desmos to come up with a y equals mx plus b for me. So it's not for sure, so it's going to kind of estimate. It's going to get as close as possible. So I'm going to put in an equation. You see my table of values has x1 and y1. So instead of putting y equals mx plus b, I'm going to write y1, and then instead of the equals, I'm going to put this little tilde sign. That means regression. Regression is come up with an equation to fit the data. Think of it as y is approximately equal to, because we've seen this sign before for approximately, mx1 plus b. Okay, so look what I've done. I've asked Desmos to come up with a y equals mx plus b that's pretty close to these dots. And so it drew me a line. It doesn't quite go perfectly through the dots, but it's not bad. It's a good line of best fit. Okay, and if I zoom into what Desmos has given me, it says that a close line to these data points is the line y equals 2.1x plus 10.5. See, that's the M and the B that it found, 2.1 and 10.5. And for now, you can ignore the statistics that are listed. So if we look at this line that it drew, sure enough, the y-intercept of the line looks like it's about 10.5. There it is, 0, 10.5. Okay, and then the slope is 2. So that's a pretty good line, but maybe we could do better than that. So in grade 10, we learn about quadratics. And quadratics look like this. Y equals ax squared plus bx plus c. I'm going to have Desmos do a regression for me with a quadratic instead of with a line. So it goes like this, a x1 and then squared. So to get a squared, it's shift 6 for that little caret sign, or accent circumflex in French, or some people call it a little hat, but it's called a caret, and that's how you get a squared, plus bx plus c. Okay, I'm going to hit enter. Oh, I didn't put x1. Okay, and now you see that I have a much better fit to the data. And this graph is called a parabola, and it's called a quadratic relation or a quadratic function. We recognize quadratic relations because they have a squared. They start with x squared. So Desmos is telling me that the best graph to fit this data looks like this. Y equals 0.3x squared plus 0.3x plus 12. Okay, and so the more you play with this, the more you'll get used to the way the equations look. Okay, and just how to use Desmos. Right, it's a very, very powerful tool, and we'll be using it a lot in our course. All right, thanks for watching.